So the vertical line test, what does it do for us? Very good. Determines if the graph is that of a function. You should be writing that down.
I already knew that.
Okay. And here you do, but when you walk out. So we looked at these examples yesterday. Is the first one a function? Yeah, because the vertical line only crosses once through these pictures. If it only crosses once, it's a function. If it crosses more than once, it's not a function. How about the second one? No, because if we drew a vertical line there, it crosses 3 times. So it's not a function. This one. No, because any vertical line there, it's not a function. Circle. Is it a function or not? No, because we do a vertical line there, it fails. This one. Yeah, because anywhere we draw a vertical line, it only touches the graph once. So it is a function. And this one? Yeah, because anywhere we go, it only touches the graph once. The only question we have here is at -1. But if we look at it really closely, the top one is a solid dot and the bottom one is an open circle. So we can only include that one. That one means open circles means do not include. So at -1, this is the only point we look at. That's an open circle. We don't use it. This is where we ended up yesterday. Now let's look at, we talk about domains and ranges. Remember what a domain was? What's that? Very good. All possible X values. The reason I say possible, because there are some times where we can't use an X value because it'll make the function undefined. And then the other one is called the range. And that one is what? All possible Y values that result from the domain. But yeah, it's all possible Y values. It sounds easy, but for some reason it gets complicated. Remember, any point on a graph is determined by an X and a Y. So we have the domain and we have the range. If I give you this equation, what's the graph going to look like of this equation? Not flip. Not, we haven't got that yet. Nope. No, it's not stretch. Because if you have a stretch, then there has to be a coefficient. Or let's say, okay, if we don't see it automatically, we can just plot some points. So when X is 0, what's Y? 0. So we have a point there. When X is 1, Where's one? When x is 2, y is 2. How about when x is -1? Y is -1. Is this a linear equation? Yeah, because x doesn't have any special. So there's our graph. Remember the example, example number 3, question number 3 we had earlier? We talked about? Since it's a linear equation, it can be written as that. That's a linear equation. What does B represent? The y-intercept. Is there a y-intercept here? Is there a B, a constant? Yes, there is. It's 0. Yeah. If there's no constant, if there's no number, it's automatically 0. How do we know that? If we set x equal to 0, then that gives us the y-intercept, right? What's my slope of this equation? What number's in front of there? A 1, which is actually a fraction, 1 over 1, which says up 1 over 1, up 1 over 1, up 1 over 1. So with this equation, what is my domain and what is my range? The domain. How far left can it go? Nope. How far left can it go? Negative infinity. How far right can it go? Positive infinity. Because that's what these arrows here say. Now, for the domain, we put your pencil on there and just cover the graph and see where it goes. It keeps on going both ways. And that's what the domain does. It goes up and down to the x values. So it goes from negative infinity to positive infinity, which we say are all real numbers. Which are all real numbers. Remember, the domain is the x. Now look at the range is the y values. Let's look at the graph. Let's put our line on the y-axis. We can go all the way down here, which is at where? Negative infinity. And it goes how far up? All the way up to positive infinity. So it's also negative infinity to positive infinity. So far, so good? Okay, now let's look at the pictures. When we talked about whether it was a function or not. When we deal with domains and ranges, they don't have to be functions. If I gave you a graph, you can tell me the domain and range. So let's say this is from +1, -1, and this is 5, -5. That's at 2, -2. So in the first one, what's my domain? Right. Why is it negative infinity, positive infinity? Because they're arrows, right? That means keep on going forever. So horizontally, it's going to go on forever. So the domain is negative infinity to positive infinity. What's my range? -1, +1, because that's it'll continue the same sequence. It's going to continue the same sequence. So the domain of that one was negative infinity to positive infinity, and the range was -1 to +1. And that's this picture. Okay, before we go any further, again, this way, we won't talk about these until section 6 of this chapter, but notice the endpoints, so the how I contain the numbers. Whenever you deal with parentheses, that means you can't get to that number. You can't use that number. Can you ever get to infinity? No, so that's why it's always a parenthesis with infinity. If it's a bracket, then we can use those numbers. So in other words, the range says my y value can equal -1, my y value can equal 1. Because again, at this point here, the y value is exactly 1. Right? And down here, the y value is exactly -1. That's what the brackets mean. So in other words, it has a bracket next to it. That means that point is on the graph. If it has a parenthesis, it never gets to it. Okay, how about this next one? What's the domain here? Is that? Because they're arrows, it's negative infinity and positive infinity. So the domain of that one the domain of this one is negative infinity to positive infinity. Okay, now comes the tricky question. What's the range? No. As I said, it's a tricky question. What's at the end of that line of both ends? They're arrows, right? Which means this one keeps on going forever. Does it stop at -5? No, it keeps on going down to negative infinity. How about this one? It's slowly going up, but as we keep on going, is it going to be higher than 5? Yeah. So this graph, even though it looks like it's bounded, it's not, because there's no set pattern of this one. That's why these two are different. This one, because we have a set pattern, it's like a sine wave. This one is just any two lines. How about this third one? What's my domain there? Let's say that is from -1. Very good. So it's a bracket, -1 to positive infinity. Because that's as far left as I can go with the graph, is at -1. I can go everywhere on the right-hand side. So the domain is from -1 to infinity. What's my range? What is it? Nope. Nope. The range is the y values, right? These arrows mean the graph goes where? It continues. Where is the graph ending on top? Where does it end on the bottom? It doesn't. So this one goes from negative infinity to positive infinity. Because if you look at it, this graph will keep on going forever and forever. Okay. Let's look at some examples now. How about the first one? What's the domain of that one? Let's go 2, -2, -2 to 2. What's the domain of that one? Yep. Bracket -2 to 2. To help you see it, put your pen. It stops at where? -2. It goes all the way to +2 and it stops. Same thing with the range, -2 to 2. So the range is -2 to 2. What do y'all, is everybody okay with this so far? How about the next one? E. What's the domain there? How far left is it gonna go? It's got an arrow there, right? So it goes all the way to negative infinity. Because it'll keep on going to the left. How far to the right will it go? Positive infinity. The range. Look at the arrow. Exactly. It'll go all the way down forever. It'll go always up forever. It's an easy concept, but it's also easy to make a mistake with this. And how about the last one? What's the domain there? Because arrow goes on forever here, and the arrow goes on forever there. So I can use any X values I want.
Oh, so whenever you said going through, it just means a specific point, but not that.
Well, this one cannot use -1. So at -1, it's not going to be -2. At -1, it should be up here. But all the X values I can use from negative infinity to positive infinity. How about my range? The range is the Y values. How far down can it go? Horizontal, looking at the Y values. Remember, this line keeps on going down forever. This one points down forever, so it goes to where? It goes to negative infinity. How far up can it go? +1. And then it's a bracket. Let me put a couple more up there. How about this graph? How far left can I go? -1, -2, yeah, the graph stops there. So it starts at -3. Is it a parenthesis or a bracket? It's a parenthesis because it's an open circle. I can't use it. How far to the right does this graph go? It stops there because this is a solid dot. What number is that? +3. And since it's a solid dot, it's a bracket. What's my range? What's the lowest the graph goes? -3. Is it a bracket or a parenthesis at -3? It's a bracket because there's a point there. The graph is there, so it's a point. How far high does it go? +3. And it's another bracket because there's a point. The concept is pretty straightforward, but it takes practice. What if I give you an equation? Let's see. What's my domain and what's my range? Let's do domain in this one. We'll talk about range later. Because the graph, the lowest it goes is -3, and the highest it goes is +3. So how about this one? What's my domain here? There's no graph to look at, so we have to know about equations. Looking at this, what rules can we apply here? What do we know about fractions? The only thing we know about fractions is for fractions, we have the numerator over the denominator. The denominator can never equal 0. The denominator can never equal 0. Because if we have, let's say 3/0, that's undefined. It actually means it's infinity. As opposed to having 0/3. That is 0. Why is there a difference between those two? Is there what? You're getting close there. This is what you said. It was just a little bit. It's here's what it means. How many times? Well, when we do 4 divided by 2, that equals what? Why does it equal 2? Because 2 goes into 4 how many times? 2 times. That's what fractions mean. So how many times does 0 go into 3? If I promise to give you nothing, how many ways can I do that? If I promise to give you nothing, I can do that forever. It's undefined. But how many times does 3 go into 0? It doesn't. So that's the difference. It's just the way you interpret it. So if we have a fraction, the first thing you have to do is look at the bottom number. Because it cannot equal 0. So always take the bottom number, set it equal to 0, and find out what x's we cannot use. So to solve for x, what do? Add 3 to both sides. So x equals 3. So when x equals 3, we got a 0 on the bottom. So what this tells us is we cannot use 3 in our answer. Because if we use 3, then we get a 0 on the bottom. So far, so good? So what is my domain? If we look at the number line, we can use everything. We can use every number except 3. How do we represent that as a domain? Well, we know we can go from negative infinity all to 3 and from 3 to, so it's 2 parts. We go from negative infinity to 3. We cannot use 3. And then we can go from 3 to positive infinity. That's this side and this side. But there has to be something between there. The union symbol, the U. That really means or. My answer is either in here or it's in here. So there's a domain for that equation. Let's do another one. You want to do another fraction one? Okay, let's do another fraction. What's my domain of that one? Actually, okay, yeah. What's my, we have a fraction. So what's the first thing we have to do? Take the denominator, set it equal to 0, and solve for x. So add 7 to both sides. X equals positive 7. So 7, so I cannot use my answer. I cannot use 7 because it'll make the bottom is 0. So I go from negative infinity to positive 7, union 7 to positive infinity. And there's my answer. Because out of a number line, 7 is the only one I can't use. Because we can't use 7, it's got a special name, actually. And we're going to talk about more about this later on, but I'll give it to you now. Since we can't use 7, it's called a vertical asymptote. Asymptote simply refers to a number we can't use. It's an asymptote. That means everywhere up and down that line at 7, we can't use that number. There can't be anything on that line at 7, up and down. All right, let's look at another one. What if it's not a fraction? How about this one? What do we know about square roots or radicals? What's that? It cannot be a negative inside there. In a square root, you cannot have a negative inside it. Now the question is, why not? Because it's impossible to get to. We know that square root of 4 is equal to what? We know it equals 2. Why does it equal 2? Because 4 is made up of 2 times 2. We have 2 of a kind. And what's the root of this equation? Remember, whatever's inside here is called the root. It's a square root. So if there's no number there, it's automatically a 2. Which tells us we need 2 of a kind to take it out. We need 2 of a kind. Square root of 36. 36 is made up of 6 times 6. Since there's 2 of a kind, we can take it out. So that's what the square root talks about. Now, can we take a square root of negative 4? 6 times 6 equals 36. Has to be the same number. 2 times 2 is 4. Can we have 2 of the same numbers that equal negative 4? Now, negative 2 times negative 2 equals positive 4. So that's why we cannot have a negative inside there. Can we do 0? Remember, we need 2 of a kind. What's 0 times 0? So the answer is 0. Whenever you have a new equation, this is how you determine what numbers you can use. Can they be negative? Can they be 0? Can they be positive? So we know we can't use negatives. We can use 0, and we can use positives. So what that tells us is this number inside here, what's the smallest it can become? It can't be negative, so the smallest it become is 0. So since the smallest it can become is 0, we set it equal to 0. So that means the smallest number we can use inside there is negative 3. The smallest number we can use is negative 3. Can we use negative 4? No, because it'll make it negative inside there. Can we use negative 2? Yeah, negative 2 plus 3 is 1. Square root of 1 is 1. So what it tells us is this. In our number line, the smallest that we can use in this example is negative 3. We can't use negatives, but we can use anything above that. So our domain is -3 to infinity. What this also means is x can be greater than or equal to -3. We use either one of those symbols. What if I had this? What's my domain there? Nope. Remember the rules that we have to talk about. We have a fraction, right? So what can you not have on the bottom? You cannot have a 0. So we take the bottom, set it equal to 0. Square root of the, but it's really this number. Set that equal to 0, we get -5. So if we use -5, then the number inside here becomes 0, which means the bottom becomes 0. So we cannot use -5. So we start off at -5 and then we go into infinity. Because we can use anything bigger than -5. Yeah, so we can mix and match these things. Okay, what if I give you this equation? What's my domain there? How is this one different than the one we just did? Ah, it's a cube root. What do we know about cube roots? Well, the cube root of 8 is what? Well, let's break down 8. What is 8 made up of? 2 times 4, which is 2 times 2 times 2. So the cube root of 8, since it occurs 3 times, is 2. The root tells us we need 3 of a kind now. Since we have 3 2s, I can take it out. Can I do that? Since I have an odd number of negatives, that answer is negative. So my answer here is -2. What does that tell us? Can we take cube root of 0? What's cube root of 0? Also 0. So we can take negative numbers, we can take 0, and we can take positive numbers. So therefore, our domain, we're not restricted. So if the root is odd, then the domain is negative infinity, positive infinity. If the root is even, only 0 to infinity. But yeah, whatever makes it 0. So the square root of x, the domain is 0 to infinity. Because that's a square. If it's even, then the domain. That's a general rule. Whatever root you have, if it's an even root, then the smallest you can have inside there is a 0. You cannot have negatives. If the root is odd, then it can be positive or negative. You're not restricted. So far, so good? Okay, let's put this to the test. What's the domain here? First off, it's a fraction. So what's a rule about fractions? You cannot have a 0 on the bottom. So what would make the bottom equal to 0? The bottom equals 0 is if x equals -1. Because if it's -1, then the cube root of 0 is 0, you have 0. So we cannot use -1. That's about the fraction. What about the restriction? What's the domain of a cube root? It's unrestricted. Cube roots can be anywhere from negative infinity to positive infinity. So the only restriction we have in this equation is this. So we're going from negative infinity to -1, -1 to positive infinity. What's the domain of this one? Does anybody know what that function means? What does absolute value mean? You've seen it before. You probably used it before, but what does it mean? Yes, basically, an easy way to think about absolute value is a distance. Let's say we're in Grand Prairie. How far is it from Grand Prairie to Dallas? Ballpark. About what? Okay, 10, let's say 10 miles. How far is it from Grand Prairie to Fort Worth? Let's say also 10 miles. But if we look at a graph, here's Dallas and here's Fort Worth. Why is it this one negative 10 miles? Because you're not going backwards. You're just going a direction, a distance. So that's why we take absolute values. Absolute values take whatever's inside there, whatever number, it's a value, a single number, and drops any negative sign it has. Again, they introduced this here, but we talk about it fully further at the end of this chapter. So are there any restrictions? Can you put negatives inside there? Yes, you can. The absolute value of -3 is 3. Remember, think of this one here, the example of Dallas-Fort Worth. This was negative direction, this was positive direction, but the absolute values are the same. They're both 10. Can you take the absolute value of 0? 0. Can you take the absolute value of +3? It's 3. It makes the number inside there positive. Not the equation, cannot be an equation. Has to be a single number. That's why it's called the absolute value. So I'm not restricted. I could put any negative number in there. I could put any positive number in there. I could put 0 in there. Next week, we're going to look at all the functions because we're using them. I'm going to show you what they really mean. And we'll talk about the domains of ranges of each one of these functions. Yeah. Any questions? This stuff will make more sense once we go through the library function. Again, I just don't like the way they organize the book. They gave you all these functions and everything without talking about the functions. This stuff will become more apparent next week when we define them.